Okay, I'm back, and so now we want to find out how can seismic waves map the inside of the Earth even more than what we already have. So we've learned quite a bit from seismic waves. So we learned that the Earth had these different parts to it. We've also learned the depths to each of the different parts. And we've also learned about the boundaries between the different parts. Well, we can go even further, because we should be able to theoretically predict the speed of a P wave or an S wave as it travels through the Earth, because we assume that the Earth is going to be, as you get deeper and deeper, it's going to uniformly get denser and denser. So we can calculate what should be the speeds at different depths inside the Earth. Then we actually did. So we actually measured the speeds of these waves by knowing where the earthquake occurred and timing how long did it take for the earthquake wave to get to a certain layer and then get back up to the surface. And so by measuring the times and the distances, we measured what the actual speed of the wave was. And what we found was that the theoretical speed did not sometimes match with the actual speed of the wave. So we found that in certain parts of the Earth, seismic waves travel faster, and then in certain parts of the Earth, they travel slower than what we think that they should be. Okay, and so they made a map of the inside of the Earth, which is illustrated by that picture there that is over there on the left. Okay, the reddish areas, the areas that are red indicate areas that are very hot on the inside of the Earth. If it's very hot on the inside of the Earth, then that means the state is going to be more liquid. If the state inside the Earth is more liquid, that means it's slower for the earthquakes to travel through it. All right, so again, red is going to mean hot. Hot is going to mean more liquid. More liquid means slower waves. All right, now let's look at the blue areas. So the blue areas are going to be relatively cool, which means that the rocks are going to be more solid, which means that the waves will be able to travel faster through them. So what we've found is that hotter areas are going to correspond to slower seismic waves. And so this is one of the reasons, or one of the ways, that we can see these convection cells coming up from the outer core. So we said that plate tectonics is run by convection cells inside the Earth. And we can actually spot these areas where this material is coming up, because it's going to be hotter, and then that's going to correspond to a certain speed for seismic waves as it travels through it. Now the other four pictures on the right shows you how does the temperature change the deeper you go inside the Earth. So it shows the temperature in the mantle. It shows the temperature at the core mantle boundary. It shows you the temperature inside the core, and you can see that the temperature is changing, and this is again showing where you got areas of convection with material that's coming up to the surface. So that's pretty impressive. It's like taking an X-ray of the Earth and seeing what's inside of it. Okay, another way that we could use seismic waves is the same way that a ship uses sonar to find a submarine. So a ship is going to send down a pulse of sound. It's going to bounce off the submarine and then come back up to the surface. And then by knowing the amount of time it took, and then by knowing the speed of the sound, they can figure out how deep the submarine was. So similarly, what we can do is send basically earthquake waves through the ground. It's then going to be reflected off of the different layers inside the earth and then come back up to the surface, and then we can use that to make a map of subsurface layers in the crust, and then we could use that to locate various kinds of ores that might be buried under the ground. So it's pretty impressive. Okay, let's take a break, and when we come back, we're going to talk about the force of gravity, and then what can gravity tell us about the inside of the Earth.